So, welcome to the new session for the exams. Um, yeah, and we can go first for the first exam example here, and here you can find what is the total accuracy for the uh, uh, following confusion metric. You can see that here this is called confusion matrix. Here you can find the predicted label, and here you can find the actual label, and here it's the actual one is 1 2 a b c, and the predicted is a b c. So now first I have to copy this. Okay, so I have made a manual table here, and I have to tell you that what we are going to get, what is the total accuracy. Okay, whatever. Let's see what is the total accuracy. So what is the total accuracy? uh, Also, so when the how accurate is, so true prediction upon total try, we can say it's like that. So um, if we get a true prediction here, so what are the true predictions? So when there was a, the predicted a, so we can say this is the true one, this is the true one, and this is the true one. So we can say here that true is 193, 173, and 189. And what are the other numbers? Is the total try. So this all numbers, the summation of all these numbers, this all numbers including the green one, is the total try. So we can say that it is 193 plus 173 plus 189 plus 7 plus 0 plus 22 plus 5 plus 10 plus 1. So at the end you will get a number 0.925. So this is the uh, total uh, accuracy. So yeah, we can go to the quiz here, and tell the Google that, not a Google but the Coursera, that it is the value here is 1925. Mm, the second question here is the total number of a true positive. What is the total number of a true positive? So we can just go to this table and mm, see what we can do. Uh, okay. So what is the true positive? The green numbers here we can see is a true positive 193 plus 173 plus 189. So true positive is 193 plus 173 plus 189, that is equals to 5. So we can see to our examiner, we can say our examiner that it's table 5 is the true positive. Now we are going to now get the F1 score of a class C. F1 for the class C. So F1 score for the class C. So first we have to um, see that what is the uh, class C. Okay. So yeah, score, sorry. Now what is the class C, F1 score C? um, so here we got formula for a class C is 2 time true positive. So we will just go, is a F1 score is a 2 time true positive upon um, true time true positive, 2 time true positive, F positive, F negative. So 2 time true positive plus false negative plus false positive, just for the uh, two positive. So what is the number of a true, so 2 time, what is the number for the true positive for a C? Okay, for C obviously is 189 upon 2 times 189 plus, okay, we can make it like this, plus false and negative. So what is the false when there was a C but not C? It's a 10 and 1, so 10 plus 1, uh, and plus the false and positive. So it is positive but false, it is positive but false, so in together 22. And the answer for this should approximately be uh, 920 point, okay, point 920. So we can tell our examiner um, that the answer here is a 0.290. Okay, now go to the, so here you can see the plot the training and validate loss over the training period of the model and see. Okay, so now okay, go for this one, copy, and we can paste it here. Okay, okay, obviously not for me. Okay, delete this one. uh, so delete this one. Okay. Okay, so first we have to take a screenshot of this M, and then we can go further. Screenshot screen. Okay, first we have to set a screenshot to say this one and paste here. Okay, so okay, so now you can see uh, the loss, how much loss while training and validation. What is the question? We will first go to the question, and then I can show you what exactly they want from us. So you plot the training and validation loss over the training period of a model, and you see the following we can conclude about this model. Okay, a loss to the time over a training and validation. So what we can predict here, Okay, so over the time, the loss is becoming approximately to zero, and in a validation set, the loss is not going to the validation. That means the uh, over the time, if there is a more data, there is a more changes in theta, and when we validate it, it is the loss is not going to the zero. That means there is much more to do, and if we predict, the model is overfitting. So the model's input dimension do not match the data dimension. That is not true, because we can see that loss is continuously decreasing over a time in the both curves. So dimension is matching actually here. So the model has a overfit over the training data. That is exactly what we want, because if the loss goes zero in a training and it does not go zero in the validation, it is obviously uh, the overfitting of the data. If the model has an underfitting, the loss here should not go to zero. The model has a good fit over the training. If it is a good fit over the training, the distance between validation and the training should be less. So we can go for the model has a overfit to the training data. One is, which of the following has a good way to try to reduce the overfit? First one is a regularization is a good way to reduce the overfit. Early stopping can be helpful, but not every time. So we can not say that that is it will guarantee the or it will guarantee the overfitting. Yeah, getting more data is actually the good thing to reduce the overfitting, and we have to decrease the complexity, not use a more complexity to reduce the overfitting of the data. So yeah, that's all from this exercise. And if we submit a send button here, then we can get a result for our exercise. And as you can see that now I got 100% in this exercise. So thank you for the view on this video. Please like, share and subscribe.